Hi, everyone. Thank you for joining us in another meetup of the OWASP Nova chapter. I'm going to mute my other screen because that's very loud. And I hope you all are in for a good night. I'm just going to really pass everything off to Jimmy. He's going to take it away. So Jimmy is the CTO and co-founder of KSOC. That's the Kubernetes Security Operations Center. And he's going to give us a talk all about the Kubernetes top 10. I want to thank all of you for joining us tonight. And yeah, that's all I have. It's been a pretty quiet summer on our side, so I'll give a little outro at the end, but I really appreciate all of you for showing up for our regular virtual meeting. And Jimmy, it is all you.
Awesome. Thanks, Ben. Thanks, Abdullah, Sean. Northern Virginia. I did jump at the opportunity to fly over there and do this in person, but this is easier on me and my family. So I am Jimmy, and we're going to talk about a very new project that I'm really excited about called the OWASP Top 10 for Kubernetes. And really today is for everybody. We're going to maybe try to recreate some sort of in-person vibe without being too much in the slide deck. But let's just kick things off, and I will share my screen. We have chat rolling. So what's key here is audience participation. That includes participation from my team, who I see some of them are here right now, so they can heckle me when nobody else wants to. And let's kick it off. So first thing I'm going to do is share these slides. Oh, Inception. How do I do that? Private chat. Well, Ben can do it. Here's a random bit.ly link that you all should click. It's not malware. Or maybe it is. You can determine that. Really, it's just a redirect to these slides if you'd like to follow along. And you know what? I'm going to open the YouTube comments up as well, so I can follow along. Because StreamYard is doing funny things when I open it and share my screen. Stand by. There we go. Just fell into the screen. Okay.
Yeah, that's Sean. Sorry. I'll pop in.
Okay.
I just put the bit.ly in the chat, so we're all good, and everybody else should be able to see it just fine.
Cool. Okay. Awesome. All right, let's get started. So I'm Jimmy. I founded a company, finding a company. I don't know what you call it. Currently building KSOC, and we focus primarily on Kubernetes security. Obviously, if you know me at all, that's literally what I've been talking about forever at this point, it feels like. So this is a new project that has been really on my back burner for way too long. It's appropriate for an OWASP meetup, and because it's an OWASP project. So again, it's the OWASP Top 10 for Kubernetes. Here's the link, and this is what we're going to talk about. Not like much other than the top 10, and we'll do a little bit of a self-audit at the end. And let's just kick things off. So the OWASP is usually not associated with infra, right? Kubernetes, cloud, all these different things. But as I dug in over the past few months, there's actually quite a few things within the like OWASP kind of greater organization focused on containers and helping kind of infrastructure security folks get up to speed. I just wanted to highlight a few of them just in case you haven't come across these. The top one, obviously, we're going to talk about the Kubernetes top 10. This is the newly minted project, but the other ones are very useful as well. One that I did participate in building last year sometime during COVID was this Kubernetes security cheat sheet. So this kind of predates the top 10. This is definitely a cheat sheet, right? If you're familiar with the OWASP projects, there's a lot more detail here on the ins and outs of kind of hardening a cluster. That's not really risk ranked in the same way a classic top 10 sort of project would be, but it's worth checking out, and even more so participating in. Like, it's not comprehensive yet, as is really nothing. So these are all living documents. But this, I've heard over the past year, this has helped quite a few people prepare for their CKS and even their kind of CKA and CKAD. Those are certified Kubernetes administrator certificates from the Linux Foundation. So this is the kind of content that can really help you kind of level up from 0 to 1 of what's going on in Kubernetes. The other one, there's a Docker security cheat sheet. There's a kind of fledgling project by my buddy Madhu, I believe. He started kicking this off, the Kubernetes security testing guide. So ideally, over the next few months, we'd have the top 10, the cheat sheet, the testing guide, and you kind of can treat all these things as your comprehensive go-to for all things Kubernetes security, which is super exciting. I've been working with OWASP for over 10 years or something crazy. I founded a chapter way back in the day. We didn't have things like this. So I'm really excited about this. So let's dive in to the top 10 itself. And I'm going to be flipping between the actual top 10 documentation and the slides, because they're a little different, but mostly get the same point across. And we'll start here. So please feel free to ask questions in chat. I know a lot of you are probably just listening in, having dinner, or should be sleeping, Steve, or the like. But the more we talk about this stuff, the better. We have an hour, and we don't have pizza and beer, so you just have me talking into the mic. So please ask questions or correct me, or live feedback is welcome. Like this is a document that unfortunately 80% of it or more came from my head, so it's probably got flaws, like most documents. So sorry we didn't order food for tonight. Yeah, it's okay. Is anybody what's everybody drinking? Is it just water? Is there beer, wine, soda water? I always feel awkward trying to crack a beer at a virtual meetup. It doesn't have the same exact vibe. It actually just kind of looks bad. So water for me, water's good. So let's break down the top 10 as it stands today. Herbal tea, awesome. I should have some of that too. So we'll just dive into number 1, insecure workload configurations. I'm not going to read these step by step, but this is the kind of rank order of whiskey. Nice. This is the rank order, at least through my experience and working with a lot of other folks. This is the first stab at kind of where these risks rank in order through, working with lots of people on their Kubernetes deployments. So we're going to step through each of these. I could be swayed to move them around. Please submit a pull request if you so wish. And just so you know, the actual project, you could see some awesome last minute pull requests going in 30 minutes ago, which is very classic. If you know me in my training, I like to really bring it to the end. But the actual project, the link's in the slides, but this is kind of the format of a top 10 project. And you can see here the navigation within this particular GitHub repo. We also have a proper page on the OWASP.org website. So we're gonna go through some slides, visit each of these, talk about them, answer questions, and kind of justify their existence. So we'll just start with number 1. Actually, we'll start with the intro. Do we need another top 10? So maybe, there are actually, if you go spelunking through the OWASP.org website, there are many top 10s. Some of them I had no idea existed. So I think it's a good place to share knowledge. So I think it's appropriate because Kubernetes itself it's these things, right? If you're not familiar, Kubernetes is a highly configurable, mature, and has no shortage of success in production. The premise here is that there are blind spots inside of Kubernetes and around that ecosystem that really are hard for security teams to wrangle at scale, right? Maybe even not at scale. Just in general, Kubernetes introduces complexity. We oftentimes at our company call it a data center inside of your data center. So it's not a single line item in your sort of security audit. It's actually a lot more than that. So I believe it totally justifies having its own top 10. You could disagree. So we'll start with number 1, insecure workload configurations. So this concept of misconfigurations is not really new to anyone. If you've been dealing with AppSec, cloud security, anything, typically breaches occur because a thing was misconfigured. It's rarely that elusive 0 day that comes from a nation state that targets your company. That stuff exists, but typically it's, I didn't know, I pushed something out in haste. Developer spun up XYZ, security team didn't catch this other thing, and a misconfiguration led to a problem. So Kubernetes, being one of the most configurable platforms in existence, is not immune to security misconfiguration problems. So that is kind of played out in the real world through breaches, but also through these surveys that you see all over the place. And what we're going to talk about is like, what is a Kubernetes misconfiguration, right? And it takes kind of many shapes and forms. So if you look here, all roads lead to YAML. So just warning, everything in Kubernetes is typically YAML, but that's something out of our control. There are many ways to configure workloads. This also kind of spans out to configuring the actual cluster components. There's also configuration when it comes to building a cluster in your cloud provider or your bootstrapping mechanism. So it's really this layered approach of configuration. What you see on the screen here is a YAML manifest for a daemon set. And a daemon set is just an individual pod running on every single node in the cluster. That's not really the important part, but under the hood, there's lots of levers and knobs and different ways to make this particular workload hardened or not. So you can see here, if you kind of go through the YAML audit, we have a lot of interesting pieces here. The first place you kind of want to look to see what's going on from a security standpoint, probably security context. Containers have security contexts as well as the daemon set or the deployments themselves. And you can find a lot of interesting information. So this in particular, privilege true, breaks down a lot of the security barriers that your container runtime gives you. So that's one thing to look out for. Sharing the host PID, host IPC, host network. These things let your container or that workload, in this case, an Ubuntu image running in the form of a daemon set in a pod, lets that particular process access more things than it really needs to or should on the host itself, right? And a lot of these combinations of issues really open you up to what we call container breakout, right? The whole concept of owning a container as an attacker. Maybe you have an AppSec, an application vulnerability or a malicious workload or something of that nature. And the attacker is able to exit the constraints of that container and ultimately have access to the host, right? The nodes that are kind of underlying this entire Kubernetes cluster. So we're not going to go through every single one of these in detail, but I think you can understand the complexity already with a single workload that is presented to you inside of Kubernetes. This is easy to misconfigure. You could even not know that you're misconfiguring something and roll it out to an entire fleet of clusters, and all of a sudden you have a serious problem. So there's a few ways that, and this makes number one for me and others because it's all encompassing. Like this is the problem that we see day in and day out. And trying to get a hold of this is not an easy task from a security standpoint. So there's some defenses, right? We're not in a situation where you need to do like some sort of static assessment of every YAML file that ever passes through Kubernetes. We typically lean towards centralized policy enforcement. And we're going to talk about that in a bit more later. But also, I should note everything in this presentation is on the open source track, right? We're not a vendor pitch or really talking about commercial tools. Obviously, there's commercial tools to solve a lot of these problems, but we're going to keep on the open source path. So one example of a way to kind of combat misconfiguration in a multi-cluster world is a project called Open Policy Agent, and kind of a sub-project below that called Gatekeeper. So this is a policy engine that lets you as the operator say, hey, I don't really want people running privileged pods or mounting this type of file system or doing X, Y, and Z in this cluster or this namespace. So let's build some and distribute some policies to actually make our security posture better at a large scale. So Open Policy Agent is a generic policy engine. You write rules in a language called Rego. It's very well supported. There are lots of other ways to do this. This is just one. I call it out here because the Gatekeeper project actually has some scanning capabilities to let you go find what, like, kind of fight fires, if you will, find misconfigured workloads and then do something about them. The second layer of defense, it's funny, there's a typo right there. Next layer of defense is actually blocking those at the front door through admission control, which we do have the capability to do with Open Policy Agents, Gatekeeper, the Gatekeeper admission controller. So, if you, as the security team, you have these 10 policies and you never want these types of workloads with this kind of shape and color to run in this cluster, you can actually block that straight up as part of admission control inside of Kubernetes. Any questions? Okay. Are we awake? Maybe. All right, let's keep pressing forward. So next up on the list, we have supply chain vulnerabilities. So it wouldn't be a security talk in 2022 if we didn't have the words SBOM, supply chain, and here we are. But in Kubernetes, this is actually a real problem, and we call it out because as pretty high in the top 10. At least it's number 2 because we don't have a great story around this still. We're, supply chain's kind of something we talk about and we have ideas, and there are some tools out there to help parts of this problem, but really we're pretty early on in our supply chain security story. So Kubernetes, SBOM, software bill of materials, correct. Supply chain in Kubernetes is fairly vast. So your images that you're importing, your applications, your Java services, your Go applications, they all are comprised of third-party software, right? Like, you're not writing everything from scratch. So we are all supposed to take a drink right now. Cheers to that. SBOM. So this is this whole kind of trust cycle, right? Where we don't know where things come from. We don't know the validity or the integrity of said, software package, or even the Kubernetes components that are being installed that construct your cluster, right? We only just now started to see cosign image verification for Kubernetes project images. So this is hard. We have some stuff available, and it's everything from CVE scanning using Claire, it's using SigStore and cosign to have kind of cryptographic integrity checks throughout your build process. You could create an SBOM, right? Oprah Winfrey style. We all get SBOMs. The key here is you need to start thinking about that inside of Kubernetes, right? Especially because we see a lot of multi-tenant clusters and environments where we have this free to fail, sort of bring your own application, do whatever you want vibe going on inside of even big enterprises. And that software could have some serious problems. So, I recommend at least checking out your base images, looking for CVEs, having a plan to act on those CVEs. And ultimately, what we want to see at the end of the day is a base image that's trusted and as minimal as humanly possible, right? Easier said than done, but it's very much the overarching goal of supply chain security. Okay, we're on to number 3. So my favorite, overly permissive RBAC configurations. Has anybody here had to deal with RBAC in their day-to-day jobs or life? Hobbies, RBAC hobbies, anybody? Probably not. So if you're not familiar, role-based access control in the context of Kubernetes is definitely a little different than when we just say it generically. It's actually a collection of Kubernetes objects, roles, cluster roles, role bindings, cluster role bindings. We combine these things together through they're very loosely coupled into giving people, humans at the keyboard, access to things, but also service accounts. And RBAC itself is one of those examples that could even be rolled up into security misconfigurations. But it's worth calling out in and of itself in Kubernetes proper in the top 10. So RBAC is number one. If you have a single cluster, it's even kind of hard to scope down who needs access to what, because think about the Kubernetes API, right? I won't pull up the API docs right now, but there are a lot of objects available, right? And each of those have verbs that they support: get, list, post, put, delete, kind of HTTP verbs. And it is pretty hard to take all those objects, combine them with the verbs in different groups or subjects, individuals, and say, Jimmy should only access these things in this namespace with these verbs. Like, that's a really hard problem in practice and in theory. So RBAC oftentimes is given too much, Jimmy, me is given too much permission, right? That ends up being the case in a lot of ways, where we give some sort of internal third-party tool, some service mesh I will not name, and some other dashboardy things, service account access to objects in our cluster that we didn't expect, or maybe it shouldn't have, or is inappropriate. So getting this right is tough, and it's very worthy of being in the top 3, if not higher up, to be perfectly honest. So RBAC work, not fun. Yep. Plenty of RBAC related findings for sure. Don't remind me. Yeah. No one says I love it. Why would it be on this list? So this is an example of an RBAC configuration. So if this was plopped on your desk one day and you were to audit it, what would you do? Well, I probably would look and see which subjects are bound to which reference. In this case, it's a cluster role. And what's interesting here, there's a lot kind of packed into, whatever this is, 12 lines of YAML. And what's actually happening here is this subject in the default namespace is a service account, right? So what we don't often expand upon or talk about is that this notion of service accounts, these things are actually automatically mounted for convenience, in quotes, into every single namespace, unless you tell Kubernetes to do it otherwise. So what's happening here is we're saying the default service account, which exists and is mounted into every pod in that cluster, is actually being bound to, what is this? Cluster admin, right? So if your workload in your default namespace gets popped and somebody grabs this particular service account, they can present it back to the Kubernetes API and authenticate as the cluster admin, right? So I'm not sure that's totally obvious when you just read this, right? This is not like, it takes a little bit of, yeah, that's a YOLO RBAC policy. You're right. But there's a lot of YOLOing happening in the world today, especially with open source software. If you were to go look, we've been doing some interesting kind of GitHub analytics, I guess, some data spelunking, and you'll find very popular projects that people throw into their cluster without really reading the RBAC associated to it. You'll find things like this, maybe not exactly this, but the premise being like, I'm lazy and this is easy, right? Because the default service account token is already there. We should just use it, right? But the best practice is to not use the default service account token because it gets shared with everything in that namespace. You should be minting these, sensitive tokens for that use case, and you should not be binding them as cluster admin. There's a lot wrong with this. So there's some tools out there to help. None of them fix the problem at the end of the day, but if we can at least visualize the total travesty that is RBAC, right? So you can see here, there's Rakus is kind of a CLI utility to give you these nice checkboxes, and you can do an audit. What is this one called? RBAC with a K maybe at the end. Another visualization tool. Yeah, there's not really a shortage of ways to visualize it, but at the end of the day, we need to do something about it, and that's the job of the security team. All right. 4 time do we have? Okay, we're doing all right. Lack of centralized policy enforcement. So this is kind of I guess a subset of security misconfigurations. So oftentimes, again, we don't have ways to tell our clusters to not allow certain things inside of them. That we have tools available. We even have built-in tools within the. I'm going to pop this open for a second. I'll zoom in. Within Kubernetes itself, right? If you're familiar with the beloved PSP, if you've heard that, pod security policy, that's policy enforcement, right? It was built in, kind of didn't really get legs because it was fairly rigid, and it didn't become the standard. It's actually deprecated now, or maybe in 124. I don't know. Don't quote me on that, but it's very close to being completely deprecated in Kubernetes. We've replaced it with other things, right? We even have it built in again through Kubernetes, the project called Pod Security and Mission Controller. And we also have plenty of open source projects here to kind of distribute policy, not for just a single cluster, but to multiple. And again, the whole premise here being like, if I don't expect a workload to enter this cluster, I should be able to stop it, right? And Kubernetes gives us this really awesome feature called a mission control that actually kind of works after authentication, authorization with RBAC. And then we have this orb called a mission control where we can block or mutate that request upon entry. PSPs are deprecated in 121. All right. Fully deprecated. All right. So don't use PSPs, and they aren't called out here in this document either. So mission control is really powerful if you use it correctly. Completely removed in 125. All right. Fair enough. I wasn't way off. So the policies you see here, classic, disallow images from untrusted registries, right? This is a gatekeeper policy, and backed by Rego. So you have this pretty easy to read sort of YAML file that says, hey, if I what do I have? Sorry, kind Kate's allowed repos. So this is a custom kind that Gatekeeper gives us. And what you're doing is giving your Kubernetes a mission control and allow list. And we're saying, unless the repo is Open Policy Agent and Ubuntu, it's not coming into this cluster, right? It's stopping, right? This stops your Docker Hub nonsense and things coming from places you wouldn't expect. So if you're in a regulated environment, you're going to want policies in place. You don't just want to be alerted when somebody did a thing. This is a pretty hard and fast kind of rule. And there's lots of these out there. And there's no shortage of Rego examples to dig into. Again, here's some examples. OPA, this is Kuborden. I don't have the name there. Kuborden is written using WebAssembly. Kyverno, which is very Kubernetes specific, but has some kind of power features if you are only looking for Kubernetes policies. It's not a generic policy engine. There's a JavaScript one. I don't know why, but you could write your policies in whatever language you feel like writing them. The key is having them there, right, and centralized and being able to go back and audit those. Okay, inadequate logging and monitoring. Yeah, I think like Sean's attended some of my like old training classes, and I always got excited to talk about Kubernetes API audit logs. And it usually is about when the class started falling asleep, when you talk about logs. But I still think they're exciting because they are full of really interesting information. Like the Kubernetes API keeps an ongoing verbose like log entry for everything that happens. Like, and that can be really valuable for your security team, your incident response team, your SOC, whoever, to ingest and do things with. So, this doesn't mean there aren't more logs. There are lots more logs to ingest within Kubernetes, but the API audit logs are really, really interesting targets to kind of help you get better. And this is an example of an audit event. It's kind of shrunk so I could fit it in a slide, but the key is like, who's doing what, right? Here's the username. You know what verb they fired off to against the Kubernetes API server, their source IP, their user agent, and if they were allowed to do the thing or not, right? This is logs are the best. This is like a gold mine if you're actually trying to like detect anomalies and stop bad things from happening, because RBAC is going to tell you like, hey, I disallowed a thing based off of this RBAC policy, or I allowed it based off of this other one. So you can take these, throw them into Elasticsearch, give a Kibana interface. If you're using GKE, you get this out of the box. Oh, Aaron Reinhardt's here. Oh, man. Who let this guy in? So these logs are great. They're seriously a gold mine. And if you're using things like EKS, this is probably already turned on, and you may just not be doing anything with them. So I suggest digging around and at least starting to run some analytics, right? Square has a really good blog post that just came to my mind called Threat Hunting with Kubernetes Audit Logs. And I'll paste it in chat. So I think there's some really cool stuff in here, right? It's like basically a rundown of all these different fields, these fields in this log entry, but things like user agent, right? If you see something that like a user agent you've never seen before hit your Kubernetes cluster, like maybe you should look at it, right? There's other types of anomalies and response status code, right? Like 500's probably bad. Something's wrong with API server, maybe. 409. All these things can be kind of combined in your overall monitoring and anomaly detection story. Can these logs be ingested into a SIM tool? They can. Follow me on Twitter for more. Yeah, you can put them anywhere. Like Stackdriver has a integration with their like Google built-in kind of SIM product. You could put them into Sumo. I mean, I think Splunk probably has some sort of light kind of analytics you can run. They understand how to ingest these things. But yeah, a good SIM tool should help. All right, it's enough about logs for 4 o'clock on a Thursday. So next on the list, we have broken authentication mechanisms. It wouldn't be an OWASP top 10 if you didn't talk about broken auth. Kubernetes is no different. And what we see is, the way this isn't RBAC authorization. Authn in Kubernetes is kind of a choose your own adventure. So what you end up seeing is a lot of shared credentials. You see a lack of enforcement of MFA. You see non-standardized authentication across multiple clusters. There's a variety of ways to mess up authentication, but it's one thing you should at least take a look at as you kind of go down your Kubernetes journey. Really, the today sort of standardized format like OIDC, enforcing MFA and some sort of MFA on your identity provider side. You could use AWS's IAM. There's lots of different ways to do this. The key is follow your authentication best practices that you already have in place. Just because it's Kubernetes doesn't mean you have to stop worrying about auth. And this is a nice little visual of how authn and authz and image control work together as a request flow. So humans access the Kubernetes API through kube control, typically, or you could just hit the API manually with a curl request if you really want to. But there's also service accounts, and they all talk to the Kubernetes API, and they all go through an authentication flow. Once you're authenticated, we'll call it OIDC, some handoffs there that happen. You're a valid user. You have the right creds. Authorization happens, and that is RBAC, and then ignition control. And finally, you can do the thing you want it to do. And those logs are actually kind of a culmination of all of these, right? You get that single point in time, that API log. So it's really useful to think of the API server flow in sort of this 3-step program. I am chasing it. I suck at Twitter. I'm trying my hardest. So 7, we have missing. I was reading chat for a second. Missing network segmentation controls. So oftentimes when you hear the words kind of Kubernetes security, a lot of people automatically go to the network side. It's one piece for sure. It's super important. The premise here being you spin up a Kubernetes cluster in EKS, give it some nodes, throw some workloads in. The default behavior is allow all, right? It's a fairly flat sort of network. There's nothing there that says out of the box things in this namespace can only talk to things in that namespace, or this pod with this annotation can only talk to that pod. So it's kind of up to you. Well, it is up to you as the operator to build, another layer of network security into these Kubernetes clusters. So there's a lot of ways to do this. And I'm not here to prescribe any of them other than the open source route, as we mentioned earlier. Kubernetes gives you out of the box capabilities to carve out network, segment your network into kind of a logical path. It's called the Kubernetes network policy. It is very flexible. It's controlled by YAML, and you basically tell it to do some selectors or match labels, and you're going to say things like namespace app can talk to namespace backend, but backend can't talk to namespace dev or whatever it is. So this is very much another configuration in Kubernetes. Now, keep in mind, you have to run a CNI plugin to leverage network policies, just a straight up cluster that uses kubeproxy and kind of IP tables won't support this. So you're going to have to use something, like a Cilium or a Calico Flannel. And those network plugins give you a virtualization layer to enable this type of network policy control. These are great. they're often used in very coarse ways, because the more granular you get, the harder it is to control and manage at like a big scale. So you'll often see things like, namespace kind of segmentation, or very broad sweeping kind of match labels. It is pretty rare to get into the pod to pod communication with network policies, because of the YAML overhead that we all have to deal with. This little logo here, Istio, is also another way to kind of handle this. Let's see if I can pull up some examples here. So a service mesh is going to a service mesh. Aaron, what are we drinking tonight? It's only 4 here, so I didn't know to bring beer. But a service mesh is going to help here as well. If you're familiar, if you've heard words like Istio, Linkerd, I don't even know if I'm saying Linkerd. I don't know how people say it. Even HashiCorp console. These act a little differently than a pure CNI plugin. Scotchy Scotch, nice. That sounds great. Except it's too hot right now for that. The authorization policy here on the screen, this is a la Istio. So you don't have to use network policies to essentially make this happen. You can actually just bring in your own service mesh and do all sorts of very fancy layer 7 routing and build policies using this out-of-the-box authorization policy. This is not a talk about Istio, so we're just going to leave it there. But all of these different methods actually give you the ability to carve out your network in meaningful ways. All right, number 8. We're chugging along. Good. Secrets management. So I got two Twitter followers catching up to you, Steve. This is good. I got 3. So secrets management in Kubernetes is, I said Istio, drink, is a thing, right? Like secrets management is a thing everywhere. It's really no different in Kubernetes. So the whole premise being, if you bring a new pod online, some workload, it probably has some key value pair that's sensitive that needs to access to do stuff. Like imagine a database connection string or an API token or really whatever. Kubernetes has a secrets object that you can use, right? And you basically can let Kubernetes store and distribute those secrets, and that's fine, but you have to understand the limitations from a security standpoint of said secrets management. So within Kubernetes, and I'll pop this open as well. The kind of the data store that has everything, all of your configuration at any given point in time, it's called etcd, and it stores arbitrary key value kind of pairs of data. It also stores secrets. So what you see here, what does anybody know what this is? This is a base 64 encoded string, like secret string. I actually remember what this decodes to, but base 64 is not a security control, right? And everyone gets all like wildly upset about this in the security community. They're just like, oh my God, how would you use Kubernetes? It thinks base 64 is secure. It's not really why base 64 is used. It does say top secret. So, the premise here is like, once this enters the cluster, it gets stored in etcd, and it's a plain text string, right? And if you want to call this secret to be mounted into your running workload, either as a kind of volume mount or injected as an environment variable, it's going to get decoded so your app can consume it. So you can use Kubernetes secrets safely. This is not a talk about like if you should. I will leave that up to your own needs and desires. but you should know the limitations, right? If etcd is popped, these are plain text strings for the most part in most clusters. You can encrypt etcd at rest, but that still might not actually matter. If you have misconfigured RBAC, you're in even more trouble, right? If you give random network plugin CNI thing that you downloaded on the internet access to list secrets in the kubesystem namespace, you just get it from the Kubernetes API. So some organizations use Kubernetes secrets safely and have kind of guardrails around it. Others omit them completely and inject secrets using something like HashiCorp Vault or your AWS KMS or whatever it may be. It's really up to you. They're really easy to use, though. I will admit it's convenient. So if you could find a way to use them, great. If you have other requirements, like even like as far as like a HSM or something, go for it, right? And here's a bunch of information on this whole default service account, what you can do to make secrets a bit safer. For those of you using Case, check out the crew plugin. View secret makes viewing them much easier. Yeah, it is a pain if you want to pull them down onto your machine. What I will say is don't check secrets into your Git repository next to your other workload manifests. I shouldn't have to say that, but they're base64 encoded, right? And, you know, if you're, I remember my first security job years ago, it was like the first question I got on the interview was like, what's the difference between encoding and encryption? Like they're different, right? Encoding is a two-way operation. Like you just decode the thing. It's just a kind of normalization format. So there you go. We have some base. I won't decode that on my screen just in case it's bad. All right, next we get into some lower level stuff. Still important, but maybe not quite as pressing from what I've seen out in the world. Number 9 is misconfigured cluster components. So the same way that we can configure workloads in the cluster, your pods, your deployments and stateful sets and all those things, your actual cluster components are configurable. So think about things like etcd, the kubelet, kubeproxy, the Kubernetes API server, all these different things that make up what we know of as Kubernetes. They all have like a million different feature flags that you can turn off and on. And some of them are really bad and some of them are benign. But this is really even more of a problem when you kind of do a DIY cluster operation. If you are building your own clusters the hard way, you have to configure the kubelet. You have to configure the Kubernetes API. There's not a lot of cloud guidance, as in like EKS and managed Kubernetes, that you can leverage. So it's up to you, right? Kelsey Hightower has the famous Kubernetes the hard way. Like you're doing that when you use COPS or KOPS or some other bootstrapping mechanism. Just for fun, I ran this survey because I found myself writing DIY clusters in the text here, and it reminded me of a survey I had out in January that I would like your opinion on, because I call them DIY or like hand rolled usually. I don't know why, but I put free range artisanal in there. I don't know what the right name is, or Kubernetes the hard way. There's lots of different ways to have that. Yeah, let's talk about your question after at the end. We'll have some time, Aaron. That looks like a real question. I can't even focus on it yet, but we will. All right, so here's another example, like one line. This is not very long. The misconfigured cluster components. So we're still on 9. So this is actually a kubelet setting, right? So if you're not familiar, the kubelet, there is a kubelet that runs on every node in a cluster. So if you have 50 nodes, you have 50 kubelets, and the kubelet itself is kind of responsible for, a fancy Docker run command. It actually takes a request from the API server and spins up a container in the form of a pod. So the kubelet has like cross VM connectivity. It has network connectivity to the outside world, ingress and egress, and you can set it up to be like totally open, like anonymous auth true, right? You can actually, I think it maybe was totally removed in like 120 or 121, but you used to be able to turn off HTTP or TLS on the kubelet. So you're basically talking about like this API floating in the ether that, doesn't have authentication or TLS, and, it's very ripe for abuse. So the CIS actually calls out some of these, right? The NSA hardening guidelines as well. There's quite a few different configurations. Some of them, if you're using managed Kubernetes, you actually don't have a lot of configurability there. Same goes with the Kubernetes API server, right? There's a server that you interact with as a user to go do things in Kubernetes, and it is basically just as configurable. In managed Kubernetes, different story, but if you're doing your own, it could be dangerous. Moving right along. The final one, 10 here, outdated and vulnerable Kubernetes components. And I see John said, Kube has 177 entries today in NVD. How does your top 10 resolve any of the findings? It's all, those are, so a CVE in Kubernetes, or something in the national vulnerability database. That's kind of why 10 exists. Like, there are CVEs, and there are CVEs in Kubernetes itself, as well as different third-party things you may inject into Kubernetes. So this is a very large catch-all. The top 10 doesn't, like, none of these individually like squash a CVE. They could help put guardrails around a vulnerable component, but 10 is really to catch those actual critical vulnerabilities that are out there. So this is a mess today, but it's Kubernetes is just another piece of software, or many pieces of software, that you have to now be responsible for patching, for vulnerability management, for all the different things that you had to do before. Now there's just more of them, and they move faster. So you want to install Istio, great, go for it. You have to now monitor the CVE database for vulnerabilities related to Istio. Argo CD, popular kind of auto GitOps CD thing that everyone uses, has a bunch of CVEs. Now it's on you to make sure you stay up to date. This is only growing. What did I say? GitOps? I don't know. I'll drink. I'm sure I said something. So you have to watch the, Istio. Yeah, Istio. I mean, I drink when I use Istio. It's just something you have to keep at the top of mind, right? So you can see here, there's kind of outline of like some CVEs in Argo. Istio has its own, quote, not quite, has its own list of CVEs, right? Like, this one's epic, right? Like, this is in 2020, so it's not today, but you're using Istio for your like nitty gritty security profiles, right? You're trying to like lock down your cluster, and they had a bypass, as you were going out and building authentication policies, that you could just present a JOT to an Istio protected, Envoy microservice, and throw a question mark or a pound at the end of it. It wouldn't inspect the JWT. That's the kind of stuff that you have to really be careful with, because you could probably go quite some time without watching the Istio CVE stream and not find something like this. So that's really, what this software factory we call Kubernetes. Like, now you're dumping a lot of work on your kind of vuln management program. And there's not one silver bullet here to kind of fix everything. You have to minimize dependencies, track these things closely, and scan everything. So we are took longer than I thought. But these are some questions. You could check out the slides. I'm not going to go through all these. If you want to ask yourself like why I'm using Kubernetes after this talk, I would understand. But you can get to a really good place. I think the top 10 is just there to help guide you, just like it is in the world of application security. My small short plug. I have a company that solves some of these. We are hosting really fun events. If you are traveling to Boston for Reinforce or Black Hat, hit me up on Twitter. I'm Jimmy@ksoc.com. And it's been a pleasure. We have a couple minutes, and I'm going to revisit Aaron's real adult question here. Let's see. What is this? How does cluster topology design impact the prioritization of top 10? That's a great question. So you're asking like, should I have many small clusters or a mega cluster? Kind of like, and what are the impacts of that on trying to like wrap our heads around all these issues? I think the cluster boundary is, in my opinion, the one of the best boundaries. I guess it's your cloud provider, like an AWS account or a GCP project is ultimately better. But the cluster boundary makes a lot of sense when you have, services that need to talk to each other. But, it's got the most networking, kind of protection, kernel level isolation. Like the blast radius is contained nicely within a cluster. So we're seeing more lean towards smaller clusters that have specific tasks to, really get us out of this. Because if you don't do that, then you have to be very good at RBAC, right? Like you have to give things access to specific objects, and that gets very tricky over time. So if you can cut it off at the cluster layer and have kind of cross-cluster communication over the network, that's probably better. But then you introduce different problems, right? Because now you're enforcing policy across 50 clusters versus 3, and that's challenging as well. But I think, a medium number of clusters based off of their criticality of the data they're processing, the environment they're in, the risk they present, I think that's the right choice. So this is a good question. For more of the topology, doesn't matter. What matters most, what's running and on the cluster. You beat me to it. Awesome. All right.
Yes.
Cool.
Oh, I was just going to say, if anybody's got any more questions, just please throw them in the chat. I tried to record them as we were going through, and you answered both the ones that I tracked. But it looks like there's one more from Neil. Do you recommend any particular tools for validating OpenShift config like Q or kubeconform?
In OpenShift, in open source land, I don't have. I mean, OpenRego will do it, but I don't actually have a good OpenShift answer. Sorry. I can definitely. I think embarrassingly ignored OpenShift for a little while now. That not intentionally. It's just it's its own beast and has some crossover, but a bunch of it doesn't. So I would imagine if you're using Gatekeeper and things like that, there are OpenShift support. But yeah, don't use OpenShift for a reason. I should get better. We should do a top 10 for OpenShift. That's the next one. Yeah. Check out Gatekeeper. I think it supports OpenShift. But yeah, I don't have any other answer. What about OpenStack? Yeah. That's still around for some reason or another.
Okay. Well, cool. It looks like we don't have any more questions. If you do, just post them in the meetup. I can reach out to you, Jimmy, or if you want to give your Twitter handle is right there on screen right now. So I'm assuming people can reach out to you if they have any questions or anything like that.
Yeah, for sure. I'm very available. So you won't have any problem finding me on LinkedIn, Twitter, wherever. So yeah, thank you for having me. It's been fun. This is like a new talk, so I would appreciate any feedback. in the form of a pull request where you go actually fix it. But seriously, if there's any feedback on the presentation, I'd gladly take it. Yeah, I appreciate everyone's time.
Cool. And again, thank you everyone for joining us. We have a tentative meeting in August, the 3rd week, as we always try to aim for. So please keep an ear out for that. And we have a couple more talks planned to end this year out. So obviously just keep listening to us on Twitter and Meetup and everything. And again, Jimmy, thank you so much for coming in, for virtually coming in and talking to us. Maybe we can get you up into the Nova area or anything like that for a live demo, live talk sometime in the future.
Let's do it. And I'll be at KubeCon, Black Hat, DEF CON, Reinforce, the floodgates are open. So, please come grab a coffee or a beer with me. I'd love to meet up with anyone. So
it looks like Aaron's going to be there at Black Hat, so that'll be fun.
Aaron, yeah, we'll be hanging out. I expect Aaron to fly in and come and meet me at the bar immediately. So we'll be there.
Cool. Well, thank you everyone, and I will see you next month, hopefully,
see you in the internet.
The next meetup we have. Take care.
All right. See you, everyone.